Now coming to sequential part. Sequential circuits. So sequential, these are, as I told, that these are basically memory circuits. They are pure memory circuits, and the basic building blocks of sequential logic circuits are latches and flip-flops, or simply you can call memory elements. So the memory elements will form the basic building blocks of sequential, and the basic building blocks of combinational are logic gates. Now in the sequential, okay, the main topics are the latches and flip-flops. So latches and flip-flops are the basic building blocks, and of course they are the sequential circuits themselves. So in the latches you will have various types of latches. There is SR latch, SR NOR latch, SR NAND latch, D latch, okay, and SR NAND latch with control input, S-R latch, active high latches, active low latches. So basically a latch is a 1-bit memory element which works on level triggering basically. And coming to the flip-flops. So what is the difference between flip-flop? First I'll tell what are the similarities between latches and flip-flops. The similarities between latches and flip-flops is both are 1-bit memory elements, okay, both have a capacity of storing 1 bit. So both are 1-bit memory elements, and both are bistable multi-vibrators, and their basic constructions will be same. Now the main difference will come, in the triggering. Latches are level triggered devices, whereas flip-flops are edge triggered devices. If the latches are getting triggered for high levels, or if they are working for high levels, then they are called as high level triggered latches, and if they are working for low level triggering, they are called as low level triggered. Similarly flip-flops, if they are working, there is working means the output changes for the clock edge. If the flip-flops are working for positive edge, they are called as positive edge triggered devices or flip-flops. If they are working for the negative edges, they are called as negative edge triggered flip-flops. But however, the basic construction will be same, only the triggering will be different, and we call latches are asynchronous and flip-flops are synchronous. Why I am focusing on the differences? Because if you sit for any interview, whether it may be PSU interview, whether it may be IIT MTech interviews, or whether it may be some software company interviews, if you say if your favorite subject is digital, the first question that comes out from his mouth, from the interviewer, is what is the difference between latch and flip-flop? If you could not answer this basic question, then you will mess up the complete interview. Your chances of getting into the company will be less, or hiring will be less. So the basic things are very important. Now, so next part is registers. So registers are nothing but they are group of flip-flops which are used to store binary information. What binary information? They can be numbers, okay, or they can be anything else. Mostly the main purpose of registers is storing numbers. For example, there is number 9, okay, the decimal number 9 is there. 9 you and me know, system does not know. System knows only the language of zeros and ones. There is the machines. So if you want to store this number 9 electronically, from the basics of number systems, this 9 can be written as 1001. Hope you know these basics. Okay, this is in binary system. Now to store 1 bit, I require 1 flip-flop. So this 1 I will store in 1 flip-flop, this 0 I will store in other flip-flop, this 0 also one other flip-flop, 1 in other flip-flop. So there are 4 bits. These 4 bits to store, I require 4 flip-flops. For every flip-flop there will be a clock. I will join all the clocks, and the circuit I will call as a register. So if I want to store this number 9, I will be storing in this format 1001 using 4 flip-flops, and those group of those 4 flip-flops I will call as a register. So basically register is nothing but a group of flip-flops where I can store certain numbers. You will find in microprocessors there are certain registers, A register, B register, C register, D register and whatnot. So why these registers? Because if I want to add 2 numbers, if I want to perform subtraction of 2 numbers, first I want to store the numbers and then I will do operations. So microprocessor will first store the numbers, okay, in the registers, and then it is going to do the arithmetic operations or logical operations on those numbers present in the registers. First is storing. So registers are storage devices in short. Now coming to the counters. So counters are basically the devices which will count. So counters are basically clocked sequential circuits which are used to count the clock pulses. What they are counting? They can count anything. So any counting, basic counting machine, the heart of any counting machine is counter, digital counter. So how it is going to count? A simple example I am going to tell you. For example, there is a movie hall. Okay, now I want to count the number of people entering into a movie hall. So whenever a person goes inside, what will happen is the states of flip-flops keep on changing for every clock pulse triggered. So when a person is going into the movie hall, let us assume that movie hall, no one is there initially. First fellow is entering into the movie hall, passing through the door. Exactly at the door, on the top of the door, they will fix a device called as electronic counter. So whenever a person is going, the electronic counter will get triggered, okay, by a mechanism of sensing, and then a clock pulse will change. That clock pulse will be recorded by this counter. Second person is going, again the triggering will happen, clock pulse will be generated, and okay, the states of the flip-flops will change and it will be recorded, so on. So how many persons are getting inside the hall? Those many triggers will happen in the electronic counter that is fixed on the top of the door, and the states of the flip-flops will change, and you can decode it and you can display the persons, okay, you can decode the number of persons, okay, using some display unit. So not only this, in any of the processing industry, whether it may be a Colgate industry, whether it may be a any manufacturing industry where you can manufacture. For example, you take a simple Colgate industry. In a simple hour, in a single hour or 2 hours, hundreds of Colgate products will be coming out. Manually it is not possible to count. So what they do is they make use of machines called as counters to count these things. So there are a number of practical examples of these counters. So registers are basically storage devices, counters are counting devices in short. Now finite state machines. So these finite state machines are basic sequential circuits where the machine, there is sequential, machine means the sequential circuit will be passing through some finite states. Okay, it will be passing through finite states and it will be having some application, or it will be having some purpose based on the application or design. So and these finite state machines, which are basically sequential circuits, are of two types, the Mealy machine and the Murray machine. In the Mealy machine sequential circuit, the present output depends on the inputs of the system as well as the states, present states. Whereas in the Murray machines, the present output of the machine depends only on the present inputs, present states, but not on the present inputs. So whatever it may be, the Mealy machines or Murray machines, they are the finite state machines and they are used for particular applications.